Well, I wasn't expecting to make this video until 2027.
Ada!
Silksong is out, and whilst most people are busy theorising on the lore and character stories in this game, I'm too distracted thinking about the rocks. Seriously, I've been kept awake at night overthinking possible theories for what these rocks could be. And whilst it may sound easy to state what rocks are where, there's one slight problem. This game wasn't designed with geology in mind. Shocker, I know. See, when covering Subnautica it was far easier. There's many visible structures, rock textures, rock types, but in Silksong it's really not that easy. Most things are covered in vast and beautiful expanses of greenery and bugs, and whilst that won't stop me from trying to pull out as much geological information as possible from this game, I'm going to warn you now, it's pretty much all theoretical. A lot of the content of this video is going to be geology applied in theory based on small amounts of evidence and connections to how we interact with geology, not based on outcrops. So don't take this video necessarily as gospel, okay? Now, when working with Subnautica, I worked in the same way you would when making a geological map, with a bird's eye view approach. This meant connecting biomes based on rock types and making outcrops as a result. But with how Silksong is structured, being mostly a tunnel underground, we're working with a cross-section instead. This means instead of looking at outcrops, I have to face this video as if I was making a cross-section, which means rocks will behave differently, being in individual beds that you could expect to follow each other along the section. But again, since Silksong wasn't created with geology in mind, I'm also not expecting geology to necessarily follow each other. I'll try my hardest to make it as realistic as possible, but there will be discrepancies. With that said, let's get into the visible geology, starting down in the Marrow. Fortunately for me, the geology in the Marrow stratigraphically continues horizontally throughout the deep docks and far fields, so this one is at least almost realistic. The lava here is still flowing, meaning there's a source, one we'll get onto later in a more theoretical part. This lava flows fast, which is crucial, because different lava types have different speeds, and because it can so easily flow, we know it has a mafic composition, or more simply, basaltic. These lavas are made of minerals such as plagioclase feldspar, clinopyroxene, olivine and magnetite, and despite flowing they are indeed actual solid crystals, because they cool at very high temperatures between 1200 to 1070 degrees Celsius. In fact, basalt only reaches its final solid state starting at 990 degrees, which in geology terms is rather cool, so we know these lavas are still in the 1000-degree range. I'm surprised Hornet only takes 2 masks of damage. Naturally, around these lavas you'll find cooled basalts, like Pahoihois, a type of ropey looking basalt, but there will also be a very interesting reaction between the heat of the lava and the bones surrounding it. Because bones are made of calcium phosphate mineralogically, when heated by the lava they are recrystallized into a rock made mostly of calcium phosphate crystals, similar to marble, but not quite. Marble consists of calcium carbonate crystals, made when a calcium carbonate rock like limestone is heated or put under pressure. But because we don't really have an example of a calcium phosphate rich rock being metamorphosed, it's quite hard to say what this rock would become. The closest we have is phosphorite, a sedimentary rock with high levels of phosphorus. But because this would be a metamorphic rock, there isn't a direct example of what would be produced. Where is this lava coming from then? Well, we're going to have to look at a pretty unexpected area, Mount Fay, because not all mountains are true mountains. Some are volcanoes, and underlying a volcano somewhere will be a magma chamber. This will be somewhere off the map. We wouldn't go anywhere near the actual chamber, but from the chamber and volcano itself you can get offshoots called sills and dikes. Since this lava flows horizontally with what would be the stratigraphy, this would be a sill, an intrusion that flows between beds of rock. Of course, this is assuming that Mount Fay is a volcano, which, yeah, the proof is a little bit lacking, isn't it? This is why I stated that a lot of this would be theoretical, because there isn't that much actual geological evidence in Silksong. However, something important is that Mount Fay is incredibly rich in magnetite, a key mineral in basaltic rocks. The magnetite in this game isn't very true to life. last time I looked at basalt under a microscope, I didn't see magnetite crystals floating towards my lens, but it is at least proof that Mount Fay has to have key igneous components. It would explain the presence of lava from the Marrow to the far fields, as well as the presence of metals, such as the craft metals and alloys, which would be needed to build all those bells and the infrastructure, since volcanoes provide many metal deposits, such as copper, zinc and gold. This also probably means that the Citadel had an extra job for those poor underpaid underworks workers when they were in need of metals. They even have underpaid labour for metals in Silksong. It's just like real life. This will be a slightly more brief chapter since it's a very self-explanatory one, but sandstones are definitely present in Silksong, most notably in the blasted steppes and sands of Karak, as well as potentially in the wormways and the very top of the surface. There's not much explanation needed as to why. There's sand, and where there's sand you get sandstone, but there's a few more interesting things to note about the sandstones you'd find. Firstly, there's going to be lots and lots of worm fossils. In real-life geology, worm fossils called serpulids are more common than you'd think, always popping up in marine rocks like limestone. But what adds more interesting stuff to the geology is the presence of coral, particularly in the sands of Karak. Whilst it's hardly thriving anymore, unsurprisingly, corals would appear in the fossil record, making the rock not so far from real life. When I was in the Spanish mountains, I encountered an odd rock containing lots of fossils, but it wasn't a limestone. It was something called a bioclastic lithic conglomerate. Because it contained stones, it couldn't have been classified as a limestone, and I suspect something similar would occur here, where you have a sand matrix, bioclastic components of serpulids and corals, and other lithics, making its own version of a bioclastic lithic conglomerate. As also expected with sandstones, particularly in the blasted steppes, you'd find cross-bedding too, made by dune processes where dunes will move. It creates these cool concave-shaped lines in the rock that show you which way the dune was moving, and this would be especially present in the deeper sandy parts. Because the wind blows from the west, we'd expect the dunes to travel eastward, and the cross-bedding would follow this pattern. And since I can't imagine the wind change direction, given that the east side of the blasted steppes is far more sheltered and produces very little wind, we wouldn't expect to see a change in the cross-bedding either. Particularly in the wormways, you'd also expect trace fossils, a kind of fossil made when tunnels are dug through the sediment by a creature. We have many examples of this in the sandstone, and in the wormways especially, you'd expect to see straight-shaped and U-shaped tunnels in the sandstone, and they'd be pretty large. Not uncommon in geology, but definitely uncommon for a worm. But since these guys look more like invertebrates than anything, I think these tunnels could be classed as a type of thalassinoides, a tunnel created by what we think was crustaceans tunneling through the sand. Okay, so we've run out of visible rocks. What next? Well, in places such as Greymoor and Shelwood, we can see stones have been used to pave the ground, and they're not as mysterious as you think. In order for a rock to be viable for building, it needs quite a few characteristics, the main being resistant, economically viable, such as a large outcrop or not too expensive to mine, not that the Citadel would care about paying workers properly to mine them, aesthetically pleasing and not too expensive to import. So these rocks would need to be hard, cheap, pretty and nearby. And looking at Greymoor's rocks, we can see they're fairly, grey. And there is rocks in Silksongs that match this criteria. Let's go through them. First off, you may be thinking the basalt from earlier, and I don't blame you. It's nearby, quite pretty and dark, but basalt isn't great. It can firstly be full of vesicles from volatile gases escaping, which can make the rock weaker, and it can be a bit of a pain to polish in big chunks. It's also very heavy, which would make it a pain to transport up the land, and dangerous to mine since it's right next to an active lava flow. And there's many other uses for the basalt here. They're mining flintstone already, after all. Wait, flintstone? That could be another option. Flint is a building rock. In southeast England, on top of the chalk, for example, flint is abundant, so small cobbled cottages can be made from this flint. but flintstone does already serve another purpose in Silksong, such as weaponry, and I can't imagine it's true flint. It seems to act more like coal, which is an awful rock to build from, and looks as if it contains high amounts of sulfur, a mineral you really don't want to be working with when building anything. The description for flintstone also says it's a type of slate, which, wow, Team Cherry, way to make a conflicting rock. And even though it behaves nothing like slate, and looks nothing like slate, even if it was, this is a rock more made for roofing and fences, not building. However, it is used in pavements, but this flintstone most certainly isn't a natural type of slate, so it wouldn't be the slate you're looking for in a pavement, and it's a little too hot. But worry not. Remember the platforms that make up most of Hallownest and Pharloom with the bioclastic rocks? Bioclastic rocks, especially limestones, are a key building block, especially in rich places where they really like to show off the fossils they're made of. They're easy to cut, sturdy, pretty, and everywhere, which would make them a very economically viable. So I think out of any rock you can see in Silksong, the most likely building block used in these pavements are a polished version of this bioclastic rock. Of course, we do have to mention the elephant in the room. Greymoor isn't a very rich town. And yes, I hear you, but since this bioclastic rock is everywhere, it likely wouldn't have needed any citadel action to be mined. Citizens of Greymoor, Shellwood and Bonebottom in particular, though few and far between, could have mined this themselves quite easily and decorated their floors with it. We've seen this happen countless times in poorer villages, where they use their own nearby rocks to build instead of imported ones. So despite bioclastic rocks' notoriety for being associated with rich places like London, in an area it's local to, it's also a symbol of local geology and the hard work villagers put into their town to make it reflect their local surroundings. Truly beautiful. There is also a chance our calcium phosphate metamorphic rock could be used in building too. After all, marble is a key building rock. But since we have no real-life counterparts to know what the properties of this rock could be like, and the fact it's next to an active lava flow, I doubt this rock will be chosen over the much more accessible bioclastics. Okay, this part is going to be a little crazy, but applying geological processes to the surroundings in Silksong, we can assume some new rocks exclusive to Silksong could be created. In fact, when I first played Silksong and saw the bells everywhere, my first thought was, man, that's gotta make a rock. So I present to you a new term I'm coining, bellglomerates. It's a bit straightforward. Due to the sheer abundance and depth these bells reach to, it's no surprise some of them will lithify. In real life, we're already seeing this happen with plastic, producing plastic-glomerates where bits of plastic carried by ocean currents from the garbage patches are washing up on shores and literally gluing themselves together into a rock. Scary. So as the bells get less and less touched, they'd also find a way to lithify, such as through sands, muds or other sediments the bells are situated on, which would cement and stick these bells together, just like what happens with conglomerates, where pebbles are stuck together by matrix-like muds. And honestly, I'd really like a bellglomerate in my collection. It's both a shame and a great pleasure that they don't exist. And whilst it could be argued that this would actually be a breccia, since the bells are more angular than they are round, belcher doesn't slip off the tongue as much, okay? And if a plastiglomerate gets to be a plastiglomerate, then a bellglomerate gets to be a bellglomerate, alright? Another thing I've been considering is if there could be unique rocks in the void. Now, void is very, very confusing. It's a fluid, kind of, but it's also alive, so I'm not really sure what to expect. However, since it is a fluid, maybe it could precipitate something. Typically, in geology, fluids, such as heated hydrothermal fluids around vents that I always seem to be talking about in my Subnautica series, will precipitate minerals. But with the void, it's a bit more of a what-if kind of question, rather than a what would. Can void precipitate? The whole idea of a unique rock in the void is based on the assumption that void can alter geology. So please take this with a massive, massive grain of salt, a whole deposit of it if you will. If void could precipitate, what would it produce? The law states that it's not a physical thing, but rather an entity or force or power. So, not minerals and not rocks. But the void can alter and seep into things such as life, and this is going to sound crazy, but unconsolidated sediments do have life in them. A key part of our life cycle is the detritivous bacteria living in the sediment, which eat dead matter. So, this also has to assume void can inhabit bacteria, which, honestly, what's stopping it? Team Cherry definitely wasn't considering its powers towards microorganisms, so I will on their behalf, and I say yes, it's life, void can get into it. What alteration would we expect then? Well, it'd definitely change colour. It'd be darker, that's for sure. Would they still be detritivorous? You know what? Not important. What's important is its physical changes to the rock. Assuming biological processes remain unharmed, the only thing I'd expect to see is a darker colour. There is a chance that the detritus produced could also be altered by the void, but I can't imagine it to differ much from the normal chemistry, that being carbon dioxide and nitrogen compounds. Regardless, a change in colour also implies this could be a kind of metamorphism. Void-induced metamorphism. In geology, the closest thing is metasomatism, where fluid alters rock characteristics, changing full mineralogies. But in this case, since it isn't really fluid, it wouldn't be metasomatism. But assuming this could be called metamorphism, because void has technically altered it, yeah, void-induced metamorphism is the best I can come up for it. The Latin word for void, a language commonly used when making these silly science names, is inanis. So if scientists name this, I reckon it'd be called meta-inanism? But I'm not a scientist, I'm just a geology student. So screw you scientists, I say it's void-induced metamorphism. And I'm afraid that's about all I can speculate when it comes to Silksong. I really wanted to cover more of the world, but as I said, Silksong's geology outcrops are, understandably, not very well thought out. And that's fine. I wasn't expecting them to be. I think we still managed to cover a wide range of the possible theoretical geology Silksong could cover, and I think the theories I've come up with have been interesting. If anyone has any more they think they could add, or wants to challenge or add on to any of my theories, please by all means feel free to. This is really up to speculation, and I'm honestly really intrigued to hear what you think some of Silksong's potential geology could be. I'm also sorry I couldn't cover every area. Unfortunately, future geology is a bit harder to speculate on. So if I missed out on your favourite area, apologies. Regardless, I hope you still enjoyed. I know I loved making this video. And if you're new to geology, which I assume lots of you are, I hope I've interested you a little in it. Make sure to subscribe for more geology content and follow my Instagram, where I make regular geology related posts showing what goes on inside a geologist's life. Stay happy, stay healthy, and eat 5 rocks a day for their good mineral contents. See you!